Hi, this is episode 7, and we're going to be trying the audio system on this TDEC device. In previous episodes, we have found out how to read from the SD card and display stuff on the screen and all that kind of stuff, and get information from the keyboard. So we're going to be using some of these features in here. On the actual website, the LILYGO website, there is some example code which I have downloaded. There's like a zip file on the GitHub site and so on. I've downloaded the file and there is examples, but under data there is a hello MP3 file which we're going to be using. I have copied this file onto a little SD card, and the SD card is actually inserted into the TDEC device, so it can actually read it right in the root of the SD card. So I've combined bits and pieces from several of those examples and other places and some of my own code. And this is basically what I have ended up with, and actually to play an MP3 or a WAV file or whatever you've got on this LILYGO device. It has a little speaker in it. I have also looked at the actual input using the microphones in there. I sort of had it working, but not properly. I could record stuff, but there is a big lack of libraries and code available to actually use the internal ES7210 analog to digital encoder that is actually used for audio. It's a good device, but most of the examples you see on the internet uses the ESP32 ADC, which is very unsuited for this kind of stuff. So I'll be looking at that at some more detail in the future. I also have not seen any code on how to encode an MP3 file. There are some examples how to create WAV files, WAV, but that's not what we want to do. But I do not have any projects in the near future where I actually need to record audio from the microphones. There is an example in the LILYGO example folders. If you look at it, the TDEC master here says examples, and it'll say microphone. But what this thing actually does is it will input data from the microphone, but it uses a thing called VAD, ESP VADH. There's voice activation data or something like that. And what its purpose actually is to recognize when there is a voice command issued, and then presumably you can respond to it, similar perhaps to what you would do with an Amazon's Alexa device or something like that. But this is only just this very, very, very basic start that you can actually detect speech, and there's no information there on how you actually would decode what the speech was and how you would maybe save the data that you are reading from the analog to digital controller to an MP3 file. As I said, I saw some information where there are some examples for ESP32 how to send stuff to a WAV file, but not using the same A to D converter. So that needs lots more information, and I am not going to put the time into it right now. I've got some other projects I want to do first. Maybe in the future I will have a look at that, and if you guys put in the comment that you want to see that, and if there's enough responses, I will have a look at that. In any case, we have this code here. As you can see, we've got the usual Arduino H file. TDEC devs H is a file that I created. I discussed that in detail in previous episodes. needs a SPI for the screen, the SD card library for reading files from the SD card. We are using the internal display. TFT ESPI is going to be a library that you use for that. We have access to the ES7210 analog to digital controller. It does more than just the microphones, obviously. And there's audio, and there's an I2S driver. These are all built into the standard ESP32 system. And we have FS as a file system for actually reading the files of the SD card. And we are going to be accessing the keyboard for responses. This means we don't have to use the serial monitor and all that kind of stuff. We have built-in screens and things like that for doing that sort of stuff. Okay, so setting up the audio, you have a whole bunch of features here that you can turn on or off. And I've turned some of them on and most of them off to make it smaller and faster. We got 2 channels, stereo, with other words. Sample rate's 1600, bits is 16. We have the I2S port is actually 0. The record time 20 seconds. We're not actually using that. I believe that's for if you're going to be recording. And there was also a defined for ES7210 address, which defaulted to 10. I don't know exactly why that was there. It came from one of the examples that I got. But if you look at the ES7210 file, it actually simply says, okay, if the ES7210 address is defined, then undefine it. And then it defines it to AD address 00, which actually defaults to 40 hex or 64 decimal. And so there was no point in defining it over here because it was wrong anyway. Obviously, it's not supposed to be 10, and it just gets undefined anyway. So that's why this is currently commented out, just as an interesting side effect. We're going to be accessing the screen. We're going to be accessing the keyboard, and we are double checking that the board has PS RAM. Now, in actual fact, I'm not sure if it is using PS RAM. This was I found this code in one of the recording samples, which actually uses PS RAM to record into, but I left it there anyway. A couple of TFT things for how the screen should be rotated, options and so on. We're going to open an audio file. This is from the audio library. The file name we're going to be looking for, as you saw, is hello.mp3. And we are going to, first of all, open it as an audio file. Then we want to register the card type. We have a TFT reset that sets the rotation, and the TL datum is actually top left, and the color and all that kind of stuff that you fiddle with. The ESP32 version that we need to do the audio and stuff properly will have to be bigger than 2.09 or something like that. And if it is not, then it stops the compilation and it puts an error message on the screen. The I2S channel that we're going to be using is going to be channel number 1, and this is the audio setup. So it just displays a bit of information. It sets up the IS the I squared C type stuff, and double checking that the ES7210 is there. We set the codec up and some other ES7210 initialization. And here we read the key from the keyboard. if the keyboard doesn't have a key available, if you read it, it'll keep coming back with null 00. So we just keep reading it until we get a valid character. Then we have the main setup function over here. It's kind of neat when you add this the oxygen sort of comments. Whenever you hover over a function, it tells you all about it. That's why I do that. Reminds you what's happening. So there's a bunch of settings for pins and so on that is common for this TDEC device that you have to do each time. So we discussed this in previous episodes. We went through the circuit diagram and all that kind of stuff to find out what that was all about. So if you're interested in that, then go and view some of the previous episodes, starting at episode 1. Okay, so we have TFT reset, makes sure the screen is ready to display stuff on. Then we got the audio setup over here, and as I said, we put comments on there so we can see what this is all about. This is kind of neat. If it fails, it just puts error message there and it just stops there. We set the pin out for the speaker, and because we're going to be putting the audio to the internal speaker on the TDEC device, we set the volume to 21. You can make it go up or down depending on if that is loud enough, I believe. It then tries to initialize the keyboard, and again, if the keyboard's not available, we also stop. That should never happen, of course. We set the backlight. We then initialize the SD card access, and again, if it fails, we stop there. And we then get the card type, and we display a little bit of information about what we found, the card type, the total bytes that are on there, used bytes, all that kind of stuff. And then we delay 4 seconds so we can read the message, and then we are done. Now to play the audio file, we give it a file name, and we go to the SD card and says, okay, does that file exist? And if it was found, then we actually open the file. Then if we cannot find it, then we say cannot find the file. If it did find a file, we then can actually play the file. So while the audio is running, then we loop through to read the file and display the audio. This is the main loop. Again, each time around we do a TFT reset, and then we're going to wait for the user to actually press the enter key before we play the audio file. So we read the key. If the key is enter, then we are going to play the audio file. And otherwise, if they didn't press enter, press another key, then we say, hey, that's an invalid key, and then we delay a second to go around. Pretty simple. So let's have a look if we can upload it to our TDEC device. So we got the TDEC device plugged in. I press the reset button while holding down the trackball button, so it goes into download mode. So now if I say compile and upload, we should have the compile going and uploading to COM10 on your machine. That would probably be a different COM port, but it finds it out. There we go. So let's have a look what happens. I'm going to hit the reset button. All right. So we got information there. We want to press enter.
Hello, LILYGO.
Oh, that's all that's in that hello file. Hello, LILYGO. And I said I got that from the LILYGO website, so I didn't actually use my own MP3 file, but that's just for testing, so that was good. I hit it again.
Hello, LILYGO.
Yep. So that's it. And I'm planning to do some project with this in the future, and also look at the LVGL system, and so you can actually make pretty GUIs with it and all that kind of stuff. So that will be coming in the future. But I've got a few other projects that I am working on that I want to have a look at. I'll do some videos on in the meantime. So that's all I've got for now. And don't forget to like and subscribe. There's more coming. And if you hit the bell button, you'll be notified if there's another video in this series. Until then, I'll see you guys later.